All right, well, it is 2 o'clock Eastern time. We'll go ahead and get this thing started. You are logged into the ANSI ResNet 380 update brought to you by Retrotec. My name is Sam Myers. I'm a trainer here with Retrotec. So we will kick it off. And just a brief outline of what we're doing here. We're just going to introduce the ResNet 380 standard, give the status of where it is, where it's going. We'll describe what's in it, what some of the recent changes are that's a little bit different than what you've been used to. They've thrown some definitions into this standard as well to keep things consistent. We'll talk about that, as well as diagnostic testing. And then we'll also talk about our automated testing app, rCloud, that'll help you out with some of this stuff. So again, I'm Sam Myers, the guy on the left. I'm a trainer with Retrotec, and then with me on the call here is the legendary Joe Madosh, who's been with Retrotec for a while. If you've ever tuned into some of our webinars in the past or seen some of our content on YouTube, then you've definitely heard him speak before. So a little bit about myself. I'm a trainer with Retrotec, certified HERS rater. I've conducted a lot of field tests. I'm located here in Raleigh, North Carolina. And then I've spent the bulk of my career with Advanced Energy here in Raleigh, North Carolina, working as a building scientist. And Joe, I'll let you introduce yourself here.
Yeah, this is Joe Madosh, and so I have put most of my time behind BPI and somewhat ResNet. Being a HERS rater is a challenge to maintain that if they don't have a business model. So I was a HERS rater years ago and had to let it go because I was doing more training than HERS ratings. But I do spend time on this committee for the 380 and the HERS ResNet subcommittee for equipment and how that gets applied, and even BPI, some of their committees. So I do try to make sure that I do stay involved with the industry so I can talk about these things on these kind of levels. So thanks for having me today.
Yeah, Joe, thanks for being a part of it. And while I've got you here, I'll just let you know too, we still have our trade-in program going. If you don't have one of our DM32 gauges yet, you can trade it in. You can trade your DG700 in to get some of the price knocked off of that. So if you have any questions about that, please do reach out to us. And with that, you get the adapter so that you can still use your TEC fans. And keep up with us. I know we haven't really had much going on with our blog or been too active on social media lately, but that's about to change. I'm going to be in the field doing all kinds of stuff, posting things to LinkedIn and to our blog to be able to give you guys some of the shortcuts that I've picked up in my career to make things go faster and smoother in the field. So just stay tuned for more of that content to come. And so we'll get going on the standard here. You can download this off the internet. These are the contributors. Notice that my name is not on there, but Joe's is. So he was a part of this and gave a lot of good feedback. So so we'll get going on that. And a lot of this content came from Ian Walker. If you were at ResNet this year, he presented on some of these updates. And he did a great job of talking about a lot of the research that went into it, a lot more on the technical side. I'm not going to get into that today. I'm going to just really talk about this from a rater's perspective to see what parts of these changes are going to affect you guys the most. But if you have questions about that, reach out to Ian at Berkeley Lab. And I've got to mention rCloud too, because it has a lot to do with what we're talking about today. This is our automated testing app that will geolocate your position. You can run your test off the device, whether if you're using an iPhone or Android or a tablet. It'll secure your test data, and you can generate a nice compliance report that you can send to your client or your QAD or your supervisor. And we'll get into more of that as we go. But we'll just talk a little bit about how it works. Your DM32 gauge will generate a Wi-Fi signal that will attach to your device, and you can run your tests from there. You can do blower door tests with it. You can do duct tests with it. You can also now do test ventilation with it as well. It's a new feature that was recently added into it. And it's nice because if you have a LTE or 4G signal coming into your device, it'll automatically generate this stuff for you using GPS. But if you don't have that, if you don't have internet, it'll still work, and you can just upload your stuff later on when you do have internet connection. And this is just an example of the type of report that that the app will generate for you, and it'll tell you if it'll pass or fail depending on what standards that you select, where you were located, what type of test you did, what the results were, and it just organizes everything really nicely for you. And these are some of the standards that we currently have in rCloud now, and there's always more to come. This thing's always getting updated. Everything is really organized right into the app, but right now we're going to talk about 380, and this hasn't been released yet, but it should be coming out any day now for you guys to use. And so we'll give you guys a preview of what that's going to look like and how you can use it with the 380 standard. So here we go. So where we are now, this standard was supposed to be in effect January 1st this year, but a lot of people threw a fit about that. So ResNet gave us a little bit of extra time. So where it stands now is that any building that gets a permit on July 1st or after will have to be tested to the 380 standard. And so Chapter 8 will go out, and this will come in on July 1st. So that's your date to remember. And some of the goals of the standard, they wanted to increase flexibility by adding more test options, and we'll talk about what those are. Keeping everything uniform, which means they added in definitions to show or to define what certain measurements are, such as your infiltration volume, conditioned space, things such as that. And what this does is that it reduces the need for raters to make judgment calls while they're out in the field. So trying to keep everything the same across the board. And so let's talk about ANSI too. You've heard of this ResNet ANSI standard. Well, ANSI is the American National Standards Institute. They work across a variety of industries. They focus mainly on creating and governing standards. So they sound like they may not be the most fun to talk to at a party, but this is what they do. And it's good for ResNet to partner with them because it really increases the legitimacy of their standard. So let's talk about what's in 380. A lot of it are some things that you're familiar with some slight changes. Mainly what we're talking about here is envelope leakage, so your duct tests, your blower door tests, also your duct tests, and it also goes into mechanical ventilation and duct system airflows. And it allows multiple tests for flexibility, so you guys have an option of what kind of tests you can do. And what's not included, no CAS testing. So this is airflow only. So CAS testing is still in Chapter 8. And like I said before, there's some new definitions of what conditioned space volume, unconditioned space volume, how raters should separate the two, as well as your infiltration volume and floor area. There's different metrics that you can represent this leakage in. So your CFM50, ACH50, ELA, SLA, NLA, all of that you can report your leakage and all of that. And if you've noticed in your rating software, whether you use REM or Ecotrip, you can find these options to record your blower door number in there. So this standard applies to single family and 3-story or less multifamily. There's changes coming specifically for multifamily here in the near future. It hasn't been released yet, but from all the talks at ResNet this year, it should be coming out any day now. 380 is now referenced in the 2018 IECC, which is a pretty big deal, and we'll get into that later. It has to do with blower door testing. It's also referenced in ASHRAE 62.2 for envelope leakage measurement, and it will probably be referenced in the future too for airflow measurement. So some of these differences, like I said, they're trying to keep things consistent, especially if it's going to be an ANSI standard. They're pretty strict about that. They want things to be done a certain way, and so raters just can't, make a call in the field. So they're trying to move away from that. So these are these definitions that I mentioned before, and we'll go into them one by one and show some examples of your conditioned space volume, things like infiltration volume, and those. And so we'll look at The repeated single point test is removed. So that's just you running the same test at CFM50 over and over. That's not going to be a part of 380. So 380 has your single point test and your multi-point test, and we'll get into those as well. Post baseline measurement is out. I'm not sure if many of you guys even realized that that was a thing. So now you just take your baseline at the beginning of the blower door test, and that's it. There's no need to do one at the end. So other differences from Chapter 8, remove the requirement for annual equipment calibration. So you go with the manufacturer. So if you have Retrotec equipment, you just look to us to see what our recommendation is. As of right now, your DM32 gauge needs to be calibrated every 5 years, and that's the same thing for the fans as well. And then for multifamily exceptions, like I said, there's going to be more coming out on this, but we'll get into some of those differences as we talk about some of these envelope characteristics. So as we get into these definitions that I mentioned, conditioned space volume is one of them, and a lot of that has to do with the attic and crawl spaces and basements. And so for here on the attic, a vented attic is not considered conditioned space volume, which is pretty straightforward. You're supposed to treat that as the outside, and so you do not count that into your volume. But if it's a sealed attic, you can. But the trick about that is that it has to your mechanicals installed in the home have to reflect in the load. So your HVAC equipment has to be able to serve that additional volume in the attic for you to be able to count that. Otherwise, you would leave it out. And then crawl spaces and basements, same rule. They're typically left out, but if they are conditioned, you will leave them in. And again, it has to be reflected in the load. So your mechanicals have to serve that space in order for you to count it. Floor cavity, same thing. If your basement or crawl space is not a part of the conditioned space volume, you leave the floor cavity section out. So basically what they're saying is you would define the air barrier at the subfloor. Garages, you never count it, no matter what. Even if there's a duct serving it or if they have a window unit in it, never count garage. So you'll always leave that out of your conditioned space volume. Thermally isolated sunrooms, you exclude those as well. So you'll leave those out. And a lot of times what this is, sometimes it'll be a porch that was closed in with windows or something like that that's not served by the HVAC system. And so this is where one of the changes comes in for measuring for measuring your volume. The wall cavity is a part of the conditioned space volume, and so you take your measurement from the outside. So you can't go in and measure drywall to drywall. You have to include the cavity as well. So yeah, you use your exterior measurements there. And then unconditioned space volume. Notice that we've moved from conditioned space to unconditioned space. With these ANSI standards, they want a direct line of what's conditioned and what's unconditioned. And so same language here. If it's a vented attic, it's unconditioned space volume. And then same thing for a sealed attic. Like I said before, if it's not served by the HVAC system, it's unconditioned space volume. And so going back to adding in the wall cavity to part of your volume, here we go. That is, like I said, you're going to measure outside to outside. So even if you have a home that is brick veneer, you include that brick, even though it's not technically part of the air barrier. That's how you're supposed to measure it. And part of the reason of that is that ResNet is trying to keep some of the same definitions as the real estate industry. And so they're trying to keep it consistent with that. So there's been a few arguments against it, but as of now, that's where the standard says. And so we'll talk about floor area 2 for a basement. If you're going to include this, it's got to be in a manual J, and so you've got to be able to obtain that and make sure that you can include that and that it was modeled in the manual J to be able to include basement floor area. Otherwise, you have to leave it out. And then this is one of the things that we weren't able to work around with some of the definitions, but in the judgment of a party conducting the evaluation, which would be you, you would be able to judge whether that is or isn't a part of the floor area. Garages, like I said, for floor area, it's always excluded. Sunrooms for floor area, you exclude that as well, just like it is for when you calculate your volume. Same thing for attics. Even if it is conditioned space volume, you leave it out. You don't count that as floor space. We don't live up there. And crawl spaces, you exclude that too. That'll never be floor space. So even if it's a conditioned crawl, leave it out. And so they also have definitions in here for your infiltration volume. And so this is the volume that you will be measuring. And so for crawl spaces, attics, and basements, this is area that you will include whenever you have the hatches shut. Or I'm sorry, open. That is when you will keep them. Is when you have the hatches open so that you can include that space into your test. And so here's the two methods that they have for envelope leakage tests. We have the single point and the multi-point. If you guys were paying attention in the 2015 IECC, there was no measure in there for a single point test. But since this has now been adopted into the 2018 IECC, it is. And so the single point is back, and that's a pretty big deal for everybody. And then for multi-point, once we've added that in, there's software out now to make this a whole lot easier. And so that's where the rCloud app comes in for part of this. And so once you go into that app, you can choose which one you want to do, and you don't have to do any math on the side. The software just does it for you. So envelope prep, this is a big section in the standard as well on how you prep the house before you do a blower door test. And so let's see what's included for that. So your non-motorized dampers, and so this will really play a role for ventilation. Sometimes there will be a hand damper on the ventilation line, and what it's saying here, if it's a non-motorized damper, you just leave it in its as-found position because chances are that's where it's going to stay. For motorized dampers, it's going to be placed in their closed position and not further sealed, so you won't tape over that. And so in some cases, when you have a ventilation duct, sometimes you'll come across both of these in the same line. They'll use this motorized damper to open it up all the way, and then they'll choke down the rest of it if they need to, if they're getting too much outside air. And so you'll see both in the same line. And so you leave that one found as is, and then you just leave that one shut. And these are usually power closed. And then so for your spot ventilation, things such as like bath fans, kitchen exhaust, you'll leave, and these are for non-dampered, and so usually these don't have a damper anywhere on the line itself. You leave these open, so you won't tape this off. So kind of consistent with what you guys have probably been used to. For non-dampered ventilation, for intermittently operating whole house ventilation systems, you don't seal this off for intermittent ventilation. You leave it as is. But if you have it running continuously and there's no damper on it, then you want to seal that one off. So it's important to pay attention to see how that ventilation is going to operate when you do your blower door test. It's going to be continuous or intermittent, because that can really play a big difference into your results. And so if you're going to use rCloud, it's really helpful because one thing that's going to play a role into this, especially if you're working under a QAD, which I'm sure all of you are, you're going to have to show like how you've met these standards. And so what rCloud does is it gives you just a quick checklist to go through and check off to make sure that you have left these dampers as you should have before you can run the test. And then it gives you that same thing that you input as a report at the end. So that way, if you're doing a field or file QA for your provider, this is something nice and easy that you can send over to them just to say, hey, I did confirm all this. So more on house prep for attached garages, you leave all doors and windows closed. But there is a little caveat to that. You can also set your blower door up in a doorway in the garage and to leave the garage door open if you wanted to. What I like to do is do both. I mean, this is the number that you'll report when it's closed, but I always like to see how bad my leakage is in that wall adjacent to the garage, because we usually keep a lot of bad things in there. And so it's important usually to see what that is if you're doing that for a client. And again, you can check that off on rCloud before you set up your test. And so crawl spaces for vented crawls, if you have an interior access door, you want to shut that. And then for unvented crawl spaces, you'll leave that interior hatch open. But there are some exceptions to that. If the floor is air sealed and insulated, so if they don't have their foundation wall insulated, then you can open it here, or I'm sorry, closed here. Or in a multifamily building, if 2 units share a crawl space. And then you can verify what kind of crawl space you have in rCloud if you wanted to, if you want to use that app just to help you keep everything organized. So more on house prep for attics. So if you have a ventilated attic, if it's not air sealed at the roof deck, you'll leave it shut, obviously, just to keep outside, so you're not pulling that in. The gauge doesn't think you have a great big hole, and if it is air sealed on the roof deck, then you'll generally keep that open. And then there is an exception to that too. For multifamily, if you share an attic space, then you don't want to include that. And again, rCloud will do this for you if you just go ahead and tell it what kind you have, so that way it can put it on the report. And that's how it would look. So basements kind of plays the same rule. If it's going to be a part of that infiltration volume, then you want to leave a door open. If not, you'll leave it shut. And again, too, sometimes you'll have a multifamily complex where they might share some basement space, and so then you don't want to include that at that point. So we'll talk about single point blower door tests. We're keeping it the same. You're going to pressurize or depressurize to 50 Pascal. I'm sorry. Corrections for not reaching 50 Pascal. And if you're not reaching 50, then there's probably a major issue that you want to have that builder fix before you actually record that test. So that's just one bit of advice there. And then your altitude and temperature corrections, it's going to be pulled from ASTM E779. But the nice thing about that is that if you use software like rCloud, it geolocates where you are and it automatically factors that in if you're connected to the internet. And then the other option too is to do a multi-point test, which is typically a little bit more accurate than just doing a single point. If you ask Ian Walker, it has the same altitude and temperature corrections, and then the software such as rCloud will take all of this into account for you so that you don't have to do any extra math on the side once you do a multi-point. So I would expect that, now that this software is available, more people will probably do a multi-point just to try to stay accurate. You can also see a little bit more of what's going on in the house if you do a multi-point test, so you can see at what pressure a damper opens and things such as that. And so again, here's that report of what it can what it would generate for you. It shows your altitude here. So I'm in Raleigh, North Carolina, so I'm at 282 feet. Shows the year constructed, shows the kind of test I did. So really nice to have to if you have to report that to a QAD. So we'll talk about some of the changes from single point from Chapter 8. what you would close off for, fans, chimneys, all that stays the same. For combustion appliances, they don't have to be turned completely off. You can leave the pilot on. It added a requirement to close basement door if the floor above basement is sealed and insulated, otherwise leave it open. And then again, too, in rCloud, you can go in and check this stuff off, and it'll report that to you to confirm that you did that. So single point envelope test changes, more of that, test procedure changes. So again, baseline, there's just one baseline at the beginning, so you won't have to do one at the end. There's no minimum induced pressure requirement. And then your altitude and density changes still refer to that same standard that rCloud will go ahead and take care of for you. And so we'll talk about multi-point now. Same as single point, except for multi-point. If you've been doing that, it was 15 to 60 Pascal. Now they've moved it to 10. They feel like having that lower number adds a little bit more accuracy. And again, no post baseline. They've gotten rid of that. I think one thing is they figured that nobody was actually doing it. It didn't really affect the test that much, so they saw no need to keep that in there. And then the number of pressure stations went from 7 to 5, and so 5 is now the minimum. And this is what it will look like if you run a multi-point in rCloud. And so you can see where it tested from 10 to 60 Pascal and what the readings were. It'll show what your pretest baseline was, what your flow reading was, and so it has it all there at the end. You can accept that, and then it'll submit all of that into the report that I showed you earlier. So this is something else new, correcting for single point. So if you're doing a single point test, basically what the standard is saying, if you're going to submit this as a HERS rating, you will need to add 10% to your leakage reading. I haven't gotten a specific answer as to why that is. Just from speculating, I'm thinking that they found that they were finding more leakage from doing multi-point, and they're trying to make single point match that. And so I guess 10% is that average number that they found. And so if you're adding this into REM or Ecotrope and you're submitting it as a HERS rating, you've got to do that. And so one nice thing about rCloud is it'll do that. It'll give you your flow, and then it'll give you your adjusted flow. So if you see here, the adjusted flow, this 1882 is 10% more than this 1711. And so they're finding that that's a more accurate representation of what's going on if you're just doing a single point only. If you're doing multi-point, you don't have to adjust anything. And for retrofit, if you're just doing it just for an energy audit, or if you're doing an existing home or a group of buildings, then you don't have to do that. And then in rCloud, you can tell the software if it's going to be used for a rating or not. And before we get into duct leakage too, I'll mention, I know some of these software companies like REM and Ecotrope are trying to be able to take software like rCloud and incorporate it into their software automatically. I know it hasn't happened yet, but I know some are talking about it. And so that'll, once that happens, that'll also be a nice feature to be able to streamline everything. And so we're at our 30-minute mark. We're about to get into duct leakage. Joe, Lee, do we have any questions so far?
I had a few. We tried to answer them in the background, and if they seem pertinent, I try to send them out to everybody. So okay. The one question I did get in the background was, are we promoting rCloud? And I tried to explain to a few people that some of the things that have now changed no longer allow an average user to just pull out their blower door and do a test, knowing that you probably should have done 5 baselines and made an assumption as to whether or not what your range was. If you did all that, that's great. You could do that without any additional software. Multipoint, you definitely needed some kind of software to really do it correctly, unless you're really good at math. Now all that stuff's been thrown out the window because the math is now including E779, which if you've seen some of these formulas is not easy to do either on your calculator or on a piece of paper. So at this level, you really need some type of software, whether it's your own homemade Excel spreadsheet, which I've yet to see somebody do successfully, or you need some type of software. So both manufacturers make software to help do this. I know that, and I've been helping Retrotec to be like, this is a complicated new process. So we try to integrate these solutions for you. So you'd be like, okay, I can now do this and feel compliant when I'm going to be audited. So you've still got a few more months before this is what you're going to need to do. So we want to be ahead of the curve. So when it comes out, you're saying, okay, I have this because I know the math is done and all of my things that are required in the report are also conquered. So that's why we're integrating rCloud into this. So we're showing you that this is not easy, and here's an opportunity as a solution.
Right. Yeah. Thanks, Joe. And especially for Multipoint tests, if you wanted to do that, you used to have a laptop with something on there. Now you can just use the device in your pocket, and so that's kind of where everything is heading, like Joe said, from both manufacturers. Okay. We'll go into duct leakage tests then, if that's it. So we're still at 25.
So I'm back. So I have one more question. Okay. So there was some, and there is still, not just from our presentation, but in general, about ambiguous conditions, especially go with the basement. So if half the basement was conditioned, but the other half was not, how do I use that as the volume or square footage? So if you're able to answer that quickly, it may be something we come back to, but that's one of there's some vague areas, and we talked about that yesterday, is the basement has this area of being a complicated assessment.
Sure. Yeah, sure. I was able to chat briefly with Ian Walker yesterday about that specifically, and basically what he says is that space has to be served by the HVAC system. If it's not, you can't include it, and so if it's only half, then I would include only half. So, and that's basically what it came down to. I mean, if it's there, even if it's sealed up, even if it looks like it would be conditioned, if it's not served, if not offset by if that load is not offset by the HVAC system, then you can't include it. So you'll really have to pair up and make sure that was accounted for in the manual J.
Great, thanks, excellent.
Yep. Okay, cool. We'll move on to duct leakage tests. Like I said, we're still at 25 Pascal. You can pressurize or depressurize. You can do total leakage, or you can do leakage to outside with the assistance of a blower door to equalize the pressure. Does not separate supply and return, so you got to test the whole system at one time. And it includes provisions for if you can't reach 25. If you can't reach 25, chances are you probably missed something in your test setup, or there's a massive hole somewhere in that duct system. So, before I, do a full test and report, I would just make sure that HVAC contractor, fix whatever that problem is, because it's something major. And so, again, in rCloud, you can go in and select the duct tests to the 380 standards. And so it also has a provision in there for Delta Q. I'm not going to spend much time on this because I doubt many of you out there are doing that. This is when you do a duct test using a blower door twice, when you test it with the air handler off and when you test it with the air handler on, to see what the leakage is as the system is running, and testing pressures at various points. So just know that that's a thing. It's there. There's not really a good way to do it. There's a lot of extra math involved. There's not any really good software out there to really help you out with that. And another major thing is that it's not code approved. And so here we're now in the 2018 IECC. It's not approved in that, and it's not approved in any of the past versions as well. But it is in 380. So some of the total duct leakage changes, similar to Chapter 8, except a complete HVAC system is required. And so the air handler has to be set. You can't just go test the supply side or then go test the return side and add the two together. It all has to be there. If there's ducts in the unconditioned space volume, you have to open that volume up to the outside so that you have to treat it like those ducts are in an outside space. There's a little wiggle room now in your area of uncertainty. So it's Pascal, I'm sorry, it used to be 25 Pascal plus or minus 0.5. Now it's plus or minus 3. And so here's probably the biggest change is I'm sure when most of you do a duct test, you hook it up to the return. But if there are 3 or less returns, so it says you cannot hook it up to a return unless there are 3 or less returns, or the total leakage is going to be less than 50. And so if you have a larger house that has a bunch of returns in it, like a return for each bedroom, then what this is basically saying is that you've got to hook it up to the air handler. So that's probably going to add a little bit more time for you. For some of you, if you have a lot of builders that build houses like this, but there is a provision in the standards that mentions safety. If it's going to be a safety issue getting to the air handler to hook up your test, then you can go back and hook up to a return. And so that means if you have a scuttle hole and you have to get up on a ladder and haul stuff up there, if you think it's going to be a safety issue, so there's that. Otherwise, yeah, that's what they're saying is to hook up to an air handler if you have more than 3 returns.
Do I want to clarify that. So if you still, I live in Georgia, not far from Sam in general, but in the South here, it's really common that we have a return in every single bedroom and a large return in the common hallway. So I clearly have more than 3 returns, but I do have a large return that I can use. So the clarification is if you do not have a large return, then you cannot do that. You do have to go to the air handler in order to get enough pressure that doesn't have a lot of back pressure. So if you do have a large return that you can use, then you don't feel that there's a safety. If you do feel there's a safety issue to get up to the attic with a ladder, your equipment, or even a heat exhaustion is something to be considered, then you have an option to use the large return below that's in the conditioned space. But if you do not have that, then you're really going to be, your test will not be accurate. You cannot hook it up to some return in one of the far back bedrooms and assume that you're going to be able to pressurize well the entire system. That's it.
Right. Thanks, Joe. And yeah, Joe handed me some slides too to show, especially if you're working with a builder or HVAC contractor that uses the same size cabinet over and over, you can build yourself a box. This is corrugated plastic, and so you can build yourself a sealed box that just hooks right up to it. That way it'll, cut your time down. And so this is an example of what that would look like. And it's important to mention too, if you're going to smoke your ducts, don't pull the smoke through the fan. Smoke the flex first, and then push it through with the fan after you hook it up. So don't ever run smoke through your machine. So the system prep for a duct test is very similar to the blower door. We'll go through it quickly here. This is both for total and for leakage to outside. For your zone and bypass dampers, you want all those to be open. You're really going to have to open those up anyway, because if you have your hose that's measuring duct pressure and you have a zone damper shut and you run your fan, the gauge is going to think there's a great big hole somewhere because you've got a pressure differential across the duct system. And so you're going to want to open up all those zone dampers to make sure that you've got equal pressure going through the whole duct system. Your balancing dampers, they're going to be left as found. So those are typically going to be your hand dampers that are coming off of supply branches or return branches if you have returns in your bedrooms. And then non-dampered ventilation, same as for blower door. If it's intermittent, then do not seal it off. But if it's running continuously and doesn't have a damper, then you are going to have to tape that one off. Otherwise, that's going to be a great big hole. So yeah, so that was pretty quick to talk about duct testing and setup. A lot of that setup was, pretty parallel to blower door setup as far as prepping the house. And so now we'll talk about some ventilation airflow test methods. So you can do test airflow at the inlet using a powered flow hood, which is what is in this bottom right-hand corner here. This is a powered flow hood without the hood on it. You can do airflow resistance, so like using an exhaust box. You can use a passive flow hood, which is a hood that has sensors in it instead of an actual fan to zero out the pressure. And then you can test the airflow at the outlet on the outside where it comes in. So you can use a powered flow hood for that, or bag inflation, which is a really, really old school method, but they're still allowing it. Or you can test flow in the air duct itself. And there's some devices that we'll look at for that. And again, you can do this in rCloud to add to your test. So if you wanted to test it in the duct, you can get one of these averaging flow sensors to put it in the duct, and it just measures and averages out the airflow through the duct. This is just a temporary thing you stick in there, and then you just tape up your hole when you're finished. And we have fresh air marked out because not all outside air is fresh, so we'll call it replacement or ventilation air or outside air.
Hold on this slide, so I have some comments, so go back for one.
Okay.
So first of all, there are there's Kelly, which looks like Keeley. You may see them advertised. There's Keeley and Dwyer, both make the averaging flow sensors. This is Joe Medosh's personal statements here, so these are not to reflect on Sam or Retrotec or anybody else, but the ones that are plastic, I do not recommend, and I have other people like Phil Spone, we've also concluded that the plastic ones you see in the picture are incredibly inexpensive, but they are not very accurate in terms of what you're looking for. The metal ones have a higher degree of accuracy, but here's what these things were originally used for, is that these were designed to be put into duct systems and then calibrated to confirm that these were reading their CFM and through the pressure consistently. So that means that you would put it in and you would confirm that it was in calibration, or you would calibrate it in the duct. Okay. So they're designed to really be left there. So they're designed for more of a commercial application, like, okay, I can confirm that this system is providing that much air because I use an external device. We're using them as a temporary device to put them in and say, okay, here's my reading, and that I can confirm compliance. So in theory, they're not being used as they were intended, which means they should have really been calibrated, and you can't do that. They're a device that needs to be calibrated, and you're just using it temporarily. So do use these with caution. We're trying to determine if this is really something that should stay or maybe be modified or used with caution or whatever it is. But right now, there's nothing you can do for an inline supply air measurement. Everything else has to be on one side or the other. So this is the only thing that's out there, but I'm just letting people know that be cautious about it. Of course, if it passes, you're like, oh, it works great. And if it fails, you'd be like, oh, is there something wrong with it? So do make sure that you are trying to understand how to use it, understand the K factor, understand the math that goes behind it. Both of the manufacturers are not the same, Keeley or Dwyer. So of all the things that are kind of being introduced new, this is one you want to make sure you're on top of your game. And again, I do not recommend the plastic versions.
Awesome. Thank you, Joe. And so I'm sure some of you probably deal with ERVs and HRVs. You can use these same flow hoods or exhaust box too to give you an idea of what's going on to measure that at the termination. So again, this is an example of a powered flow hood here. There's a couple of those on the market. The powered flow hood is really the most accurate way to do it because it has its own fan to zero everything out to really show you what that measurement is. A good example of that is if you're trying to see how fast a car is going on the highway, you get right behind it and see what it is on your speedometer. And so that's basically what this does to show you what the flow is. So you can use that, and that's essentially how that type of flow hood works. And then there's also the bag method, which is still kind of surprising to me that this is a thing. We're in 2018 now, and we have tools for this, but really to use this, you need a trash bag and a stopwatch. They're saying, I know Ian is a really big fan of this because of how simple it is, and there's no extra tools needed, but I don't know, sometimes the repeatability might be a little iffy if you have 2 different people running it. So, but it's allowed here in 380.
A couple things about the bag is don't assume that you know the volume without actually testing the bag itself, especially once you put it inside, this cardboard or plywood surrounding. And sometimes it takes two people, as you see in the picture, because one person is using the stopwatch to know when the bag officially was full. So it sometimes it may be cheaper to get a device, but again, they did leave it in. We're all kind of there's other places. Canada also uses this as an approved testing method, so it has its value, I guess.
Cool, thanks. So the flow at inlet terminal, you can use an exhaust box, and if you have a DM32, there's actually a setting on the gauge where you can tell it what size hole your device has. And so you can use a cardboard box if you want to. If you don't have a calibrated exhaust box of your own, you can make your own. And so this is for single branch only, so like bat fans, kitchen exhaust. So again, if your gauge knows the hole opening and you can read the pressure, then it can tell you what that flow is. And there's a setting for this too. So we have this. This is running a TEC exhaust box using rCloud, and so you can set parameters for what you wanted to comply with on what CFM, and it'll tell you if it passed or failed, depending on how many you have to test. And so more on in-duct airflows. These three grouped at the top of the right here, these are permanently installed. You probably won't see too many of these in the field and residential, but they are out there and you can use them. It is nice, but they're a little bit more pricey. HVAC contractor probably isn't going to pay to put that in, but it is an option, and you can just test it right there at the duct. And on the bottom here is what Joe was talking about earlier for the it's just a temporary instrument that you would insert into the duct. And so another thing that was added is total system airflow. And this refers to ASHRAE standard 152 and ASTM E1554 is what's referenced here. And this is essentially just measuring the total airflow of the HVAC system, measuring it from one point. And so you can actually use a duct tester. You can have the system going and measure the pressure and see what it is and then match it. And so that's what it means by pressure matching. You can read the duct pressure and then match it with your fan to see what the total airflow is of the system. And you can also use a calibrated flow plate like the one TEC makes. It slides into a filter slot. So there's several different ways you can do this. You can also use like a commercial flow hood if it'll read. If you hook it up at a return, you can use that as well. And so we'll talk a little bit too about equipment accuracy, since this does fall back on the manufacturer. Now we'll talk about the sum. And Joe, I'll let you take this section.
So a lot of people are, panicked. There's lots of social media about how accurate is your gauge, and so if you compare the difference between 1% of the manometer reading, or even just a fraction of a Pascal that's required, right, versus the fan, which is allowed to be 5% of your reading. So if you determine that if my gauge is off by say 2%. What does that actually do to my reading versus my fan being off by 5%, which is allowed, or if it's even off by more than 5%. So what I try to do, and the slide on the left was kind of altered, but if you go to focus on what's on the right, if I'm reading 936.4 CFM, and it's allowed to have a difference of 5%, you can see that my readings are plus or minus 47 CFM. That's in tolerance for what's allowed. So the point is that people really kind of focus on the gauge when they really should be focused on the fan. How accurate is your fan? How many times has your fan been dropped off your truck or rolled down the street or been abused? Or how old is your fan? When was your fan last calibrated? you probably had your gauge calibrated or know that it's coming up soon, but have you been doing your field checks with your fans and confirming that they are in calibration or had it calibrated? So I do think the manufacturers are going to be considering adding fan calibration over a course of many, many years, but just to kind of confirm whether or not you're falling within the 5% accuracy, because you could be off by 7%, 8% and realize that your numbers could be quite a large scale. So the point is focus on the accuracy of your fans and how well they're tuned up versus exactly your gauge. Your gauge, it's either on or it's actually way off. It's not that common for the gauge to be 3% off. It's usually like, wow, there's a problem with the gauge. But your fan could easily slip slightly based on alignment of the fan blades and a variety of those kind of conditions. So your fan is really your highest focus in terms of being well maintained. There are a variety of good questions in the background, some of which I may not be able to answer or we can't answer immediately, but we do have your name and email information, and we will try to follow up something if I can't get to it before the webinar ends.
Great, cool. Well, we are actually at the end now, so if we have some questions, we have a few minutes. We can address some of those.
One question was, Ben asked, is that are flow boxes or the exhaust fan flow meter allowed in the 380? He says he didn't think it was, and I know it is. I'm just trying to find the actual chapter verse to show that. Gotcha.
Yeah, it's definitely allowed.
The other one, which I'm also trying to look up, is are large vane ammonometers with a capture hood acceptable, which means that there are capture hoods that use a vane ammonometer as their measurement device, which I'm sure that I can't imagine that's not. But one of those was if you're using the Testo, I can tell you that the Testo does not comply in terms of usually it doesn't read large enough for some of that. So if you're using, I think it's the 477, some they have limitations that may not actually fit the requirements. So I would definitely confirm some of these for Ben, who asked some of these to confirm if these are acceptable. Are there any other questions that anybody had about can do or how to do or what's in or what's out of the house?
Yeah, there was one. Steve was asking, he has a lot of flat roofs in his area with ducting between the ceiling and the roof deck. It's unvented attic space that is not large enough to get up and inspect, and there's no access to it. Would you consider that to be inside conditioned space or not? And do the ducts have to be tested for leakage to the outside?
So yeah, there was another part to that. If you cannot access it, then you don't include that part into your conditioned space volume. So like, for example, if you have a house too and you cannot access a part of the attic to test that, then yeah, you don't include that in part of the conditioned space volume. And what was the second part of that question?
Do the ducts inside the conditioned space have to be tested for duct leakage to the outside?
Yeah. So if you can't include that part as your infiltration volume or your conditioned space volume, then yeah. But if you really don't have, it doesn't sound like you really has a way to open that up. So that's one of those special cases we can look into a little bit more and get back with you on that. Yeah, that's a good one. Do we have anything else in the question box?
I've been asked how long in general does it take to does the test take, and I guess that those are multiple different tests that you're doing right there. So the multi-point is clearly a much longer test. If you're not used to doing a multi-point test, it does have its a little more time that's involved. The one thing I can remind people about, if you're going to do the multi-point test in for rCloud, that, and this is universal, it isn't just rCloud itself, that if you leave the app, let's say you're like, well, I'm going to do my multi-point test, I know it's going to take 3 or 4 minutes, and you decide to go check your mail or go do something else while using that same device, that rCloud cannot run in the background and continue to do your tests. You must have rCloud active. That is a safety feature that's built into Android and Apple all the time. That means you're not allowed to run things in the background incidentally. So it means if the app is no longer active, it no longer can control or capture data in the background for those kind of things. So if you're going to run a multi-point test, you must leave rCloud active while you're doing that type of a test.
And another thing too, you can also change the range on your fan while you're running a multi-point test. And it's a little different between Apple and Android. On Apple, it's right in your face where you can see it. Android, you are able to, but you have to go in and find that setting. But you can change the range while you're running the test. You don't have to stop and start over.
Ben also asked if it takes longer to perform a test with rCloud than it does Fantastic, or which one takes longer. Fantastic, if you're doing an auto test, will capture more points in both directions and more bias pressures. So rCloud is faster.
Great, thanks, Lee. Did we have anything else?
A couple people asked about will rCloud work with a DM2, and it does not. It requires Wi-Fi. And
right.
DM2 does not have a Wi-Fi.
There's a question about what happens if someone opens a door during a test. Do you have to restart the whole test, or can you start from a certain point?
Usually, it will. What's going to happen is you're going to get alerted as though you're out of range. So what you can do is pause it because now your test Pascal just went crazy. You exceeded your 50 or went below, so it's not going to read anything. So you're able to just pause it, fix the conditions, and then hit resume, and it will go back to 50. And you can't go to a different spot in the test and then start again. That's too difficult in terms of being able to control the data so that people can't try and make some kind of alteration. So the test has to be start, continuous. You can pause to change ranges or fix a condition, and it will resume and log that data when it goes back in range. So you're not going to log data if you're at 75 pascals when you're trying to do a single point test. Right? So you must be within a certain range to do that. So same if you're doing a multi-point test, you're only going to log the data when you're in the range of you're doing that multi-point. So if it goes from 10 to 60, there's different areas you're going to test. And if you're not in that different pressure reading, you do not log, right? So that's why it's really specific and why it's very accurate to use these types of devices to go, okay, all of my tests was done accurately because it only logged the data when I was reading at those requirements.
Cool. Well, we're at our hour, at our 3 o'clock mark here. If you're looking for any more past webinars that we've done, everything's on YouTube at the link there /user/Retrotec Energy. So we have lots of content posted there. If we didn't get to your question, we'll look through them and get back to you. And just want to thank everybody for attending. Appreciate it.